Hey everybody, welcome back to the channel. So today we are going to be discussing some solubility rules, and also we're going to be going over the word reactions worksheet for our chem quiz. Sorry, I know it's a little bit late, but yeah, let's get into it. Okay, so remember, with our word equations, we're going to look at it, right? And it's basically just naming from the words. So also, remember your diatomics. Brinkelhoff, Brinkelhoff, Brinkelhoff. I know I said that in the last video, but continue to remember that. Okay. So first, let's do Al because aluminum is not Brinkelhoff. And then O2 because it's aluminum metal reacting with oxygen gas to form aluminum oxide, which is just Al plus O2. And put your little arrow. And then that is going to get you to Al2O3. And the only reason I know that is because when I look at my ionic periodic table, or whatever you call it, the thing with all the charges on it, it tells you the charge of aluminum, which is 3, and the charge of oxygen, which is 2. So you get that. And then we have to balance, because you can't just leave it like this, because clearly this is not balanced. Okay, so what I'm going to do is first I need to put a 2 here, because when you see a 3 and a 2, often it's going to have to be 6 to be equal. So that, if I do that, put a 3 here. Now that's balanced, our oxygens are balanced, but unfortunately we have 4 aluminum, so let's just put a 4 in front of here. And there you go, that's a balanced equation for aluminum metal reacting with oxygen gas to form aluminum oxide. Okay, let's go ahead and look at this next one. Dimanganese heptoxide will decompose into manganese metal and oxygen gas. Okay, I think I also forgot to put, but this is synthesis. I'm just gonna, this first one is synthesis. So dimanganese, remember our naming, dimanganese heptoxide. Let me look. Don't believe that is on my periodic table, but I have the key that I'm looking at. Dimanganese, okay, yeah, it's just covalent naming, it just took me a minute. So di means 2, so M2O7, 2 manganese metal, so just Mn plus O2 because Brinkelhoff. Then we have to balance. So you obviously can't leave it like this. And because there's a 7 and a 2, what I'm going to do, I'm going to put 2 here and a 7 here to make it both 14. And then now we have 4 of them. Oh, I did not put an N there. Well, there's supposed to be an N there. You guys knew what I was talking about. Just put a 4 here. Again, balanced equations. So this is our word reactions. Also, you could be looking at like, if it was like a double displacement, you'd be looking at some solubility rules. I will pull out the worksheet that I posted the key to on Google Docs as well, to just go over some other stuff too. So this is just decomp, so we don't have to worry about our solubility rules. Okay, for this one, zinc metal, so just Zn plus iron 3 oxide, so Fe2O3, to form iron metal and zinc oxide plus ZnO. Yeah, because they both have the 2 charge. Okay, so now let's get to metal. Let's go to balancing. So there needs to be a 3 here to balance that, and then there will also be 3 to balance the zinc now, and then there needs to be a 2 here. So now we have a balanced equation yet again. And not to mention, this is, what is this? This is a single displacement. If I could actually use words, that would be great. And so I'm gonna cut, and we are going to go on to our next problem. Okay. Now let's go ahead and look at this next one. So sorry if the last one had a weird cutoff. I kind of forgot to like hit the pause button. Anyways, carbon monoxide, CO, easy, plus water, H2O, also easy, love that, to form CO2 and hydrogen gas, H2. Brinkelhoff, again, write it down, remember it. This is double displacement. I mean, CO, H2O. Yeah, double displacement. I think. I don't know. believe it's double displacement. Solubility. They should both be soluble because, yeah, I'm not going to worry about that with this one because it doesn't have PMS castor bear. So there's no lead, there's no mercury, there's no silver, there's no calcium, there's no strontium, there's no barium. And I don't think there's any other rules that apply here. So yeah, let's just go ahead and move on. Okay, let's go ahead and take a look at these next three. Okay, ammonia. Ammonia is produced. Okay, so this is synthesis. So ammonia, NH3, is produced when hydrogen gas, so H2, plus nitrogen gas, N2. Okay, so let's balance it. There has to be 3, put a 2, because that'll be balanced because you have 2 nitrogen on both sides, and then you have 6 hydrogen on both sides. Unless I did that wrong. Did I do that wrong? It's quite possible, knowing myself. Nope, I did it right. Okay. And this is synthesis. Just wanted to double check that with the key because I have it up next to me just to make sure that I'm showing you guys the right thing so I don't confuse you guys on the test. Okay, calcium carbonate. CaCO3. Remember, they both have the 2 charge, so don't worry about it with writing the little, like, thingies. Anyways, decompose into calcium oxide, so CaO, because they both have a 2 charge, plus carbon dioxide, CO2. And that's already balanced, and that's decomposition. So with these word type equations, just look for some keywords. So like decompose, obviously, decomposition, produced, synthesis. It's look for some keywords, and also once you're writing out your equations, that should also like make sense too. Okay, now we're gonna look at solid iodine. So Brinkelhoff, I2 can be added to chromium oxide, so CrO, because they both have a 2 charge of chromium 2 oxide, to form chromium 2 iodide, so Cri2, no, Cri, well, chromium 2 oxide, wouldn't that be, hold on, let me look at my periodic table, if I can find chromium 2 plus, well, it should be, Ms. Artanis, what are you doing here? I think she did this wrong on the key because I'm pretty sure chromium has a 2 charge and iodide has a 1 charge, so I'm pretty sure there should be a 2 here, but I'm also going to Google it so I don't tell you guys the wrong thing. Then it also creates oxygen gas. So I'm actually going to plug this into Google real quick. So I2 plus CrO. Yeah, no, I'm right. It's Cri2. Yeah, I was right. So she just did it wrong on her key. I don't know what she was thinking, but chromium 2. Obviously, it's a 2 charge, and iodide has a 1 charge, so there has to be a little 2 here. Or that's oxygen. True here. Duh. Okay, so I'm gonna go ahead and do some balancing. Let's see, there needs to be a 2 here because there's 2 oxygen. There also needs to be a 2 here because there's now 2 chromium. There needs to be a 2 here because there's now 4 iodide. Okay, so that should be balanced, and this is single displacement? I believe it's single displacement. Okay. So that is one of the quiz review worksheets. Pretty simple. I honestly prefer the word equations because I feel like they're easier. Okay, let's go ahead and look at the next worksheet and go ahead and talk about some solubility rules real quick. So for this particular worksheet that I posted like as a practice, all of the reactions work. But it's also good practice. So I already did these and they're posted as the key, but let's just go ahead and look at it. This is some help with solubility, and then I'll take a look at the worksheet that we did in class on Friday and just talk about some other stuff to remember, because I know there's a lot of charts she gave us, a lot of stuff to remember. but we're going to get through it together. Okay, so let's look here at sodium nitrate plus potassium carbonate, and that turns into silver carbonate and potassium nitrate. So silver carbonate is a solid or insoluble because, if I can pull out my little lovely thing I have here, one of my charts, the one that's on the back of the predicting products cheat sheet, with like the 1 through 5. Anyways, so for number 5, it says all carbonates, phosphates, chromates, hydroxides, and sulfides are insoluble except when they are combined with alkali metals or the ammonium ion. Silver, not an alkali metal. Obviously, it's not ammonium either, so therefore it's insoluble, meaning it's a solid. Potassium nitrate. All nitrate, chlorate, perchlorate. Nope, that doesn't apply to that. Anyways, nitrates are always soluble except for PMS castor oil. So lead, mercury, silver, calcium, strontium, barium. And also group 1 is also always soluble. And potassium is group 1. It's an alkali metal. So yeah, there we go. That's just a quick example from this worksheet. I have the key posted. Yeah, let's just go ahead and look at the worksheet we did in class real quick, and I'll look at her key, obviously, to make sure that I did everything right, and just go over some stuff that might be confusing. Okay, so obviously there's a lot of work on here, and we did this in class. Like I said, keys posted on Classroom if you guys want to go look at that. But I just thought I would discuss briefly, just to discuss. Okay, so number 1 is works because, okay, remember, I'm going to drill this into you guys. Please listen to me when I say this. If both solutions are aqueous, the reaction can't occur because they're both soluble. It just doesn't work. In order for a reaction to occur, there has to be some sort of insoluble compound within it. So like, or 2 insoluble, which is a rare occurrence, but Miss Right-China said it can happen. But if there's 2 aqueous, it won't work. Remember, 2 aqueous does not work. So if we look at 3, this doesn't work because both copper chloride, copper 2 chloride, and aluminum bromide are aqueous. So therefore the reaction doesn't occur. That's why there's a little X there. Originally, she also said that, I think it was number 6 didn't work, but it does because calcium chloride is a solid. So, yeah. Anyways, let's look at this one. This reaction works because, remember, cross-counter charges, we went over that earlier, but but remember, cross-counter charges, like I said in the last video, and I've always said, aluminum chloride is aqueous, but Hg, it's mercury, right? Yes, mercury. Mercury iodide is a solid because PMS castor bear. And so what I'm going to recommend for the test is have your little pamphlet. I have mine right here with all my solubility rules. My camera's not focused, but love her. She's very helpful. Also have the little cheat sheet that has this stuff on it. Very helpful. Also, the stuff on the back of this is a little bit helpful, but you'll have to write some extra stuff on it. So I would just say, just use your little pamphlet and the thing on the back of the cheat sheet she gave us because that's helpful. And obviously your ionic periodic table because she helps with so much. And your charges and everything. So this one, let's look at number 2. This one works because silver phosphate is a solid because, I'm going to pull out my little chart. It says, all carbonates, phosphates, chromates, hydroxides, and sulfides are insoluble except when they were combined with alkali metals or the ammonium ion. Silver, not an alkali metal, clearly not ammonium. So, therefore, it's insoluble. And then KNO3, nitrates, and group 1 metals are always soluble, so obviously she is aqueous. Let's look at number 3, and I think this is the last one we're going to go over because the key is posted, but feel free to text me with any questions or anything like that. Okay, so copper 2 chloride. Let me look at my little sheet. Chlorides, bromides, and iodides are soluble with the exception of silver, lead, and mercury halides. And PMS castor bear, obviously. But copper is like not an exception. It's not silver, it's not lead, it's not mercury. So it's aqueous, you know. Chlorides are, I think for the most part, pretty aqueous. I can't say that word. Aqueous, whatever. And then aluminum bromide. Like it says here, chlorides, bromides, and iodides are soluble with the exception of silver, lead, and mercury halides, and obviously PMS castor bear. Aluminum does not apply to that, so therefore it's also aqueous. So both of these are aqueous, meaning there's no reaction because you wouldn't be able to see it. Okay, so that is all we're going to go over today in this video. If you guys have any questions, go ahead, reach out to me, and yeah, I hope you guys feel prepared. God bless.